Mopay nga kulob sa iyong atanan. Welcome to my channel. So for our topic for today, this is a continuation of sample problem we have solved last meeting. So under the topic Technique of Integration, Unit 2, Transformation of Trigonometric Formulas. So before we start, I would like to emphasize that we are only dealing with a certain types of function. That is the integral of sine raised to mx, cosine raised to n, x dx only. And as you can recall in our last discussion, we have four conditions that we need to meet before we proceed with our integration. We need to examine first the power or the exponent of certain function before we can apply the power formula, the use of substitution, or use some trigonometric identities to simplify our function before we proceed with our usual integration process. Okay, so moving on, let's proceed to our next example. That is example number 10. Can be found in your workbook on page 83. Okay, so example number 10, evaluate the integral of sine cube 3x cosine raised to 5 3x dx. Okay, so what is our first procedure when we're starting with our solution with this kind of function? Of course, we need to examine the power or the exponent of our given trigonometric function. So we'll do some manipulation to align our function to our condition before we replace it with some trigonometric identities or use some substitution. So for this function, that is integral of sine 3x cosine raised to 5 3x dx. Okay, so we'll start with sine raised to 3x. So it's obvious that if we're going to rewrite or manipulate the power of this function, we can rewrite this as sine squared 3x times sine 3x. So we all know that if we're going to multiply the power of these two functions, it's also equal to 3. Okay, so we rewrite that function with our new manipulated function. So that is integral sine squared 3x quantity sine 3x. And of course, copy still the remaining. That is cosine raised to 5 3x dx. So what is our next move? We're going to use the trigonometric substitution. As you can recall, in your condition B, we have sine 2 3x is also equal to 1 minus cosine squared 3x. So we're going to use this substitution based on the power, or we're going to use this substitution to replace our existing function. Okay, we rewrite the function using our substitution. That is quantity 1 minus cosine squared 3x. So still copy the remaining. So that is sine 3x cosine raised to 5 3x dx. So what is our next move? So we need to expand this binomial by distributing its neighboring function inside the quantity. So what will happen? If we're going to distribute the neighboring function to inside the quantity, that is sine 3x cosine raised to 5 3x. So that is when we multiply this function inside the quantity 1, and minus the second term, that is sine 3x. So cosine raised to 5, cosine raised to 2, that is cosine 7. We add the power. So copy the base 3x. Okay. So you already expanded. Of course, don't forget your dx. Now, our next step is to apply our property number 1. As you can recall, our property number 1, we distribute the dx and the integral inside the quantity. In doing so, our term will be divided into 2. Okay. So, integral of sine 3x cosine raised to 5 3x, of course our dx, minus the integral of sine 3x cosine raised to 7 3x dx. Now we have two terms. Okay, so we apply our property number 3. So that is our correction factor. So we need to determine our correction factor. So in this case, we use cosine 3x assure u. So we let u equal to cosine 3x. If we get the first derivative of our cosine 3x, there would be negative 3 sine 3x. Therefore, your correction factor dx is equal to 1 over negative 3 sine 3x du. Okay, we apply our correction factor to the two terms. Since cosine 3x is common in both terms. Okay, let's apply the correction factor. That is integral of sine 3x. So cosine 3x, we replace it with our u. So that is your u. Don't forget your power. That is 5. Then dx, that is your correction factor, 1 over negative 3 sine 3x du. So we'll do the same to the second term. Sine 3x, we replace cosine 3x with u. Don't forget the power 7. Then your correction factor, 1 over negative 3 sine 3x du. Okay, so our next step is to cancel some common terms. So that is sine 3x, sine 3x, sine 3x, sine 3x. So we have a remaining of real number constant, that is 1/3. So we carry out that real number constant using our property number 2. So we move our real number constant outside the integrand, that is negative 1/3 integral of u, your raised to power of 5, and your du. Then the other term, that is negative times negative, that is positive 1/3 integral of u 7 du. Now we can apply our power formula. Okay, if we apply our power formula, that is negative 1/3 quantity u 5 plus 1, 5 plus 1 plus 1/3 quantity u 7 plus 1, 7 plus 1. Okay, so we have negative 1/3 quantity 1 over 6 u 6 plus 1/3 1 over 7 u 8. So that is 8 since that is 7 plus 1. Okay, so finally, our answer, if we are going to multiply, okay, this is negative 1 over 18. So that is u6 plus, okay, that is 1 over 24 u8 plus c. Then we can recall our value for our u, which is cosine 3x. Okay, we rewrite our final answer. Negative 1 over 18 cosine the power 6 3x plus 1 over 24, your cosine, your power 8 3x plus your arbitrary constant. So that is your final answer for example number 10. If you have comments, you can comment down below, or you can send me a message in our group chat, or you can send me your personal message through your Moodle account. Okay? For the students that are not yet subscribed, you can subscribe to our channel to keep updated with our video weekly. So, proceeding to our next example. Example number 11. Okay, example number 11 can be found in your workbook on page 84. Okay, so example number 11, we need to evaluate the integral of sine raised to 5 2x cosine raised to 5 2x dx. Okay, always if we're dealing with trigonometric formulas, we need to do the usual procedure. We need to check and evaluate the exponent or the power of our function so that we can align those power or exponent to the existing substitution or identities, trigonometric identities. So we can replace it through substitution. Okay, for this problem, our solution is, so integral of sine raised to 5 2x cosine raised to 5 2x dx. Okay, so start with sine. We'll start with sine raised to 5 2x. So we can reduce the power. So we break sine raised to 5 2x to certain power which is equal to itself. Sine 2x sine squared 2x squared. So if we expand the power, it became 4 plus the power here 1, so still sine raised to 5 2x. We just reduce and expand it to be more convenient in our side, so we can easily replace it with some identities and use the substitution method. Okay, so rewriting our function, that is integral of our new form. So that is sine 2x quantity sine squared 2x raised to 2, then the remaining cosine raised to 5 2x dx. Okay, so what is our next move? We use the identities. Okay, the identities. So the identity of sine squared 2x is also equal to sine squared 2x is also equal to 1 minus cosine squared 2x. Okay, so we replace this quantity with our identities. Okay, so rewriting sine 2x quantity, we replace it with 1 minus cosine squared 2x. Then the remaining cosine raised to 5 2x dx. So our next step is what? We're going to expand. So remember, this is squared. So that is times 2 or to the power of 2. So we can expand that binomial. So let's start here with expanding our 1 minus cosine squared 2x squared. If we're going to expand, that is 1 squared minus 2. The A is 1 and the B is, so cosine squared times 2, that is 4 cosine 2x. Then your B is still the power, that is cosine 4 2x. Okay, so rewrite, that is 1 2 cosine to the 4 power 2x plus cosine to the 4 2x. So this is our expanded binomial. So we put it back to our function. So integral of sine 2x quantity 1 minus 2 cosine 4 2x plus cosine 4 2x, and the neighbor is cosine 5 2x, so dx. So what is our next step? We let the neighbor join the house, so the quantity goes to, doing so, equal integral of sine 2x, so 1 pa lang, we're going sa 1 ha, then the other one cosine 5 2x, then we proceed to our second, so minus 2 sine 2x, then the cosine raised to 4 2x, then to our third, so plus, so sine 2x, then cosine raised to 4 and cosine raised to 5, that is, you add the power, okay, that is cosine 9 2x. Okay, so the closed quantity, we have dx. So usual, we can apply our property number 1. So we let the integrand and the dx. So to be clear, this is 9, okay? So this is 9 power. We add 4 and 5. So applying our property number 1 to separate each term. So the resulting would be 1, 2, 3. 3 terms already. Okay. So we apply integral of sine 2x cosine raised to 5 2x, so dx, minus, we have a real number constant, we carry out outside the integrand, so sine 2x cosine raised to 4 2x, so our dx to complete our function, plus integral of sine 2x cosine raised to 9 2x dx. Okay, so our next step is to use our power formula. Remember, in condition number 1, it stated that if at least one of the exponent is equal to 1, so we can apply power formula. If the condition is met, we can proceed with power formula. If not, what if the power of the other function is not yet equal to 1? Or you can still proceed to some procedure, or you can expand, reduce, whatever, factor out, the binomial, whatever method that will simplify your function and meet the requirement of the condition. So you can replace it with some substitution. Okay? So in this case, since one of our function, trigonometric function power is 1, we can apply our power formula. So in this power formula, we can apply power formula, but we need to balance or simplify first our term. So before you can apply your power formula, you need to apply your property number t, which is your determining your correction factor to simplify and proceed with your power formula. So in that case, we let u equal to what? We'll choose cosine 2x since it's common to every term. So cosine 2x. If we get the first derivative of our cosine 2x as negative 2 sine 2x. Therefore, our correction factor dx is equal to 1 over negative 2 sine 2x du. Then we can apply our correction factor and replace our cosine 2x with our letter u, since that's the letter that we choose. So let's continue. The integral of sine 2x. So cosine 2x, we replace this with u, but we remain the power. So your dx, will you replace it with your correction factor? Negative 2 sine 2x du minus 2 integral of sine 2x. So that is u. Your power is 4. With your correction factor dx, negative 2 sine 2x du. Then our last term plus sine 2x, your u to the power of 9 plus your power correction factor, this negative 2 sine 2x du. Okay. So your next step is to cancel out common term. So sine 2x, sine 2x, sine 2x, sine 2x, sine 2x, sine 2x. So we have a remaining real number constant 1/2 in each term. So you can apply your property number 2 to carry out outside the integrand and proceed with your power formula. So let's carry out this real number constant, that is 1/2 integral of u raised to 5 du. Here at second term, you have a common term, that is 2. You cancel out 2, but you still have negative. So you need to multiply the existing sign. So negative times negative, that is positive. So your 2 is already cancelled out. So the remaining is, so integral of u raised to 4 and your du. Plus here, so negative 1/2. So replace our sign. Since positive times negative is still negative. Okay, so that is negative 1/2 integral of your u, your power 9 du. Okay, so you can proceed with your power formula. Okay, let's do some okay, let's proceed with our power formula. So that is negative 1/2. So quantity u 5 plus 1 all over 5 plus 1 close plus That is your u. Okay, let's review our solution first. So this is sine 2x first term 5 2 sine 2x 5 going here. This is supposed to be 9, right? In our expansion, squared 2a. Okay, this is supposed to be 2 only. I'll do some correction here, okay? This is supposed to be 2. And if we're going to power b, that is cosine. Okay, that is correct. Okay, moving back. So this is supposed to be 2. Okay. So, okay, that is check. Here, 2, correct. Sine 2 as correct. Then here, set 2 and 5, this is supposed to be 7. Okay, it's okay. Now here, that is correct. Cosine 4 and 5, that is 9. So the same. So we only have correction here. This is supposed to be 7. That is correct. And our power here, this is supposed to be 7. And here also, this is supposed to be 7. Okay. I think I corrected my error. Okay, so proceeding with our power formula, you have u 7 plus 1 over 7 plus 1. Glow negative 1 half our 9 plus 1 over 9 plus 1 plus c. Okay, continue. That is negative 1 half times 1 over 6 u6 plus 1 over 8 u8 minus 1 half times 1 over 10 u10 plus your arbitrary constant c. Okay, so we recall our u. What is our u? That is cosine 2x. So if we rewrite our final answer, that is negative 1 half times, that is negative 1 over 12. So we recall our u, our cosine, then our power 6, 2x plus 1/8 cosine raised to 8, 2x. Okay, so here, negative 1 half times 1/10, that is 1 of 20. Cosine, power of 10, 2x plus your c, your arbitrary constant. Okay, so that is your final answer for your example number 11. So I guess it's getting somehow heavy, but you just need to be vigilant and be, for example, here in our expansion, we need to be careful in our expanding our certain function, because if we encounter error, for example this one, we encounter error, instead of 2 we write it 4, right? So it will have an effect going down to your equation. So look at the error. the result of the error. So you need to be careful in expanding your function or your identities in order for you to get the correct answer also. Okay, because whether if you apply your power factor correctly, you've determined your correction factor correctly, but you encountered some error, like here what I've encountered, I have an error on the power. So everything, each term is involved with its error. Okay, so I hope our example number 11 is clear and you get some techniques and ideas in handling types of trigonometric function. Okay, so let's move on to our next example, example number 12. So example number 12 can be found in your book on page 84. Page 84. So what is our example? So we need to evaluate sine squared quantity 1/3 x dx. Okay, so what are we going to do? Again, it's a combination. It's a combination of what? It's a combination of two functions, or we can use identities right away. But before that, of course, let's observe and evaluate the given function. That is integral of sine squared 1/3 x dx. Okay, what are we going to do to simplify our 1/3 x? Okay, let's determine the correction factor first. We apply our property number 3. If we let Ru equal to 1/3, 1/3 3x, therefore our first derivative would be 1/3. Then our dx is equal to 1 over 1/3 du, or that is 3 du. Okay, so if we apply our correction factor to our function, it's integral, so sine squared, we replace our 1/3 3x since it's our u, and our dx with our correction factor, that is 3 du. Okay, so we apply property number 2, carry out real number constant. So 3 integral of sine squared u du. Okay, so in our function, it's much simpler. We just apply correction factor. So our function is ready for integration. Not yet. We need to use some identities. That's why this topic is substitution. So we replace our, based on your condition number 2, so we replace our sine squared u with, that is 1/2 1 minus cosine 2u. Okay, so we replace our sine squared u, 3 integral of 1/2 1 minus cosine 2u du. So here we carry out real number constant, applying a property number 2, that is 3/2 integral of quantity 1 minus cosine 2u du. Then we distribute property number 1. Distribute our real number constant. So carrying the 3 halves. So 3 halves integral of 1 du minus 3 halves integral of cosine 2u du. Okay, so if you're going to evaluate this one, integral of 3 halves, the same du, that is u, minus, here, if you're going to integrate our cosine 2u, that is 1 half sine 2u, then plus c. Okay, so 3 halves u minus 3 halves times 1 half, that is 3/4 sine 2u plus c. But we need to still recall our u. What is the value of your u? 1/3 x. Okay, we replace our u with 1/3 x. So 3 halves times 1/3 x minus 3/4 sine 2 times 1/3 x plus c. So we rewrite 3 halves times 1/3, that is 3/6, or we can reduce it to 1 half x minus, copy, 3/4 sine, that is 2 times 1/3, that is 2/3 x plus c. So that is your final answer for your example number 12. 1 half x minus 3/4 sine 2/3 x plus c. Again, if you have question, you can message me to our GC, send your personal message through your Moodle account, and comment down below this video if you have some question. Okay, moving on to our example number 13. Example number 13. Okay, example number 13 can be found in your workbook on page 85. Okay, so we'll evaluate the integral of sine squared y cosine raised to 6y dy. Okay, our step is what? For solution. Still are common. So we need to break some power to make it comfortable to evaluate the function. To start with cosine raised to 6y. Integral of sine squared y cosine 6y dy. That is also equal to sine squared y. If we're going to break 6, so we rewrite it to cosine squared y cosine 4y. So still 6. 2 plus 4, that is 6. And your dy. Okay, so our next step is to utilize sine squared y and cosine 2 cosine raised to 2y. So we have an identity. So we replace it with the substitution, that is sine squared y cosine squared y is also equal to sine y cosine y squared. So we will lift our power to close these two function or these two terms. Okay, so we left this power to close these two functions. So if that is the case, that is sine y cosine y squared. So we use this two common power. So sine y cosine y squared. So it's still the same. So copy the remaining term, that is cosine raised to 4 y dy. Okay. So our next step is to use this identity. Sine y cosine y for substitution is equal to 1/2 sine 2y. Okay, so we can replace this one. So that is quantity. Instead of sine y cosine y, we replace it with 1/2. 1/2 sine 2y, since 1, 2, 2y. Close, then still your power and your remaining cosine raised to 4 y dy. Okay, so we apply our power. So distribute this power back inside the quantity. Okay, so integral, if we're going to apply our power here, so 1/2 power of 2, that is 1/4. So sine 2y power of 2, that is sine squared 2y. Okay, so that is 1/4, 1/2 squared, that is 1/4 sine, so it will become squared 2y. Then the remaining cosine 4y dy. Okay, so what are we going to do next? Let's always make it a habit to observe the power. Okay, so here we have real number constant 1/4. So we can move that 1/4 outside the integrand. So sine 2 raised to 2y, it's already stable. So we move to our next term, that is cosine raised to 4 cosine raised to 4y. So we can break cosine raised to 4 to cosine squared y squared. If we're going to multiply these two power, it's the same, 4. And of course your dy here. Then use the identity. We have an identity for cosine squared y. For cosine squared y is also equal to 1/2 quantity 1 plus cosine 2y. That is your condition number 2. Okay, we replace our cosine squared y with this trigonometric substitution. So 1/4 integral of sine squared 2y, quantity 1/2, that's quantity 1/2. We replace this with a bracket to make it clear. Replace it 1/2 quantity 1 plus cosine 2y. Remember the power 2 and your dy, don't forget your dy. Okay, so what is our next step? Since we have a common power of 2, we combine this term. So power of 2, common power. So integral. So we join this sine squared 2y inside the bracket. So sine, but instead of squared 2y, we use it as common power. So it will become sine 2y times 1/2 and quantity 1 plus cosine 2y bracket squared then r dy. Okay, so what are we going to do? We need to what? Rationalize. So we still have power. So if we're going to multiply our 1/2 both side, a real number constant 1/2, we multiplied both sides to sine 2y and quantity 1 plus cosine 2y. The resulting function, oops, I think we forget the 1/4. Wait, we have 1/4 here, right? Okay, we have 1/4. Okay, so if we're going to multiply 1/2, it will become sine 2y quantity 1 plus cosine 2y all over 2. Then your power 2 dy. Now, we multiply this sine 2y inside the bracket. Okay, so 1 over 4 integral of bracket. So sine 2y times 1 still sine 2y plus sine 2y times cosine 2y, that is sine 2y cosine 2y all over 2 bracket squared dy. Our next step is to bring in the power back, distribute it back inside. Okay, so if you're going to distribute this power of 2 back inside, so that is 1/4 integral of bracket, so power sine squared 2y from the 2, from power 2 plus sine, so it will become all squared. Or simply, we can write it a simpler one. We write it quantity sine 2y plus sine 2y cosine 2y quantity squared. Okay, so how about for our 2? It will become 2 squared. Let's close the bracket, dy. Then we apply our power here. This will become 4. And we need to expand this quantity. If you're going to expand, that is 1/4 integral. So let's expand first. So if we're going to expand, we move our common power 1/4. Okay, let's expand. Okay, so a sine squared 2y positive, so this is positive 2 times a, that is sine 2y, then for our b sine 2y cosine 2y, then plus our b squared sine squared 2y cosine squared 2y. Then of course we close the bracket and our dy. So we simplify, we combine some common terms, and let this bracket 1/4, the real number constant, out. Okay, so 1/4 times 1/4, that is 1/16. Okay, so we combine some common term. Okay, so sine squared 2y plus a constant number sine 2y times sine 2y, that is sine squared 2y, then cosine 2y plus, of course, square root of b, that is sine squared 2y, then cosine squared 2y, then our dy. Ooh, it's kinda getting into my eyes. The function is getting long. So we apply property number 1. We distribute in so that we can divide this term. Okay, of course, including 1/16. So we distribute by applying our property number 1. That is 1/16 integral of sine squared 2y dy plus our real number, or later since it's included in the function. So that is 1/16 integral of sine squared 2y. We have 2 sine squared 2y and cosine 2y of our dy plus, oops, our 16 again, that is your dy plus 1/16 integral of sine squared 2y cosine squared 2y dy. Okay, so we have three terms. So we need to deal with this term separately. So 1, 2, 3. Okay, so I think we need to continue to the next page. We don't have enough space for this one. So moving on, we'll move to our next page. Okay, so let's recall back our remaining 3 terms. That is 1/16 integral of sine squared 2y dy plus 1/16 integral of 2 sine squared 2y cosine 2y dy plus 1/16 integral of sine squared 2y cosine squared 2y dy. Okay, so we have 3 terms. So we need to evaluate each term separately. Okay, so we need to deal with that separately. Okay, let's mark our terms so that we'll not be confused. So this is our term 1 Because we have a 3 separate solution for this. 3. Okay. So let's start with number 1. 1. That is 1/16 integral of sine squared 2y dy. Okay. So what is our observation with this? Okay. So what are we going to do? Sir, find the correction factor so you can have a stable function. Okay? So it's a good idea. So if we apply our property number 3, our correction factor, if we let our u equal to 2y, therefore our first derivative is 2. Therefore your dy is equal to 1/2 du. Okay, apply your correction factor to your function. 1/16 integral of sine 2u and your correction factor 1/2 du. Okay, so carry out your correction factor. So that is 1/16 times 1/2. That is your 1/32 integral of sine squared u du. So what is our next step? We can use some substitution. So for sine squared u is also equal to 1/2 quantity 1 minus cosine 2u. Okay, so we replace our sine squared u. So that is 1/32 integral of 1/2 quantity 1 minus cosine 2u. Of course, don't forget your du. Okay, so we're okay. So we carry out this real number constant, that is 1/2 times 1/32, that is 1/64 integral of quantity 1 minus cosine 2u. Of course, our du. So next step, property number 1 again. So we apply our property number 1 again. So we distribute our 1/64 inside. So if we're going to do that, that would be 1/64 integral of 1 du minus 1/64 integral of cosine 2u du. Okay, so we're done with our, so we need to solve them. So so this is 1/64, so that is u minus 1/64. So the integral of cosine 2u, that is 1/2 2u. So 1/2, so of course that is negative sine 2u. So simplify further. So 1/64 u. Okay, so would be 1/2. Okay, this is only one. This is only 1/2 sine 2u. Okay, so 1/2 times 1/64, that is negative 1/128 sine 2u plus c. Are we going to check? Let's check. 1/64. Okay, sine 2, okay. So we recall our value for u. What is our u? That is your 2y. U is 2y. Okay, we rewrite our answer. 1 over 64, 2y minus 1 over 128 sine 2y plus your arbitrary constant c. Okay, so we're going to rewrite our final answer. So 2y, so common, that is 1 over 32y. Then minus here 128 over 128 sine 2 times 2, that is 4y. That is plus c. So that is your answer for your first term alone. So this is for first term alone. We to solve for our second term. Again, class, it's getting heavy, right? But you just need to be resilient answering trigonometric functions. Okay, we can use other color for our term number 2. So we use green. Okay, so let's copy our term number 2, that is 1 over 16 integral 2 sine squared 2y cosine 2y dy. So what are we going to do with this? Sir, same with our term number 1. You can use correction factor. Okay, so what correction factor we're going to use? Let's use sine 2y as our correction factor. So applying our property number 3, our correction factor is, so we get u equal to sine 2y. So if we're going to get the first derivative of sine 2y, that is 2 cosine 2y. Therefore, our correction factor dy is equal to 1 over 2 cosine 2y du. Okay, apply your correction factor. 1 over 16 integral of 2, you replace your sine 2y. If you're going to replace your sine 2y, you replace with u, then remain the power, then copy the remaining cosine 2y. Your dy will replace as your correction factor, that is 1 over 2 cosine 2y. So du. Okay, so we'll do some cancellation. So common 2, cosine 2y common, so the remaining is du. So if you're going to rewrite it again, 1 over 16 integral of u to du. Okay, so now we can use our power formula. If we use our power formula, that is 1 over 16 quantity u 2 plus 1 all over 2 plus 1 plus c, that is 1 over 16 times 1/3 u raised to 3 plus c. Okay, so 1 over 16 times 1/3, that is 6, 8, 4. 1 over 48. Then replace with u. We recall the value of our u, which is sine 2y. Sine, so what is the power of our u? 3. Sine 3 2y plus c. So 1 over 48 sine 3 2y. So So this is your answer for second term. Second term. We still have the third term. Whew, whew. Okay, so let's move to our third term. So let's use blue again. You have a limited color here. So for your number, your term, third term, so copy, that is 1 over 16 sine squared 2y cosine squared 2y. Okay. So like what we did in our previous example, we can combine the power and expand, right? You can see it in your example number, I think that was number 12 or 11. So we combine the power to expand this trigonometric function. Okay, let's do it. So we can rewrite this. Okay, 1 over 16 integral of, we combine the power, so that is sine 2y cosine 2y squared dy. Okay, our next step is to get the identities of the sine 2y and cosine 2y. Sine 2y cosine 2y is also equal to, if you're going back to your condition, that is 1/2 sine 2x. Therefore, sine 2y is equal to 1/2 sine 1/2 sine 2y. Okay, let's rewrite our function. That is 1 over 16 integral of quantity 1/2 sine 2y. Oops, don't forget your power. You still have 2 dy. Okay, so if you're going to apply the power, what's inside the quantity, it will become 1 over 16 integral of, so 1/2 squared, that is 1/4. So sine squared 2y dy. Okay, can we use another identities? Yes, we have identities. So in this case, we carry out real number constant because there's no other quantities here. So we can, if we're going to 116 times the real number constant 1/4, the remaining inside is sine squared 2y dy. Since we have also a trigonometric substitution for our sine squared 2y, we can use that. Okay, so 1/4 116 times 1/4, that is 30, that is 1 over 64. Okay, 1 over 64 integral of, we can use our identities here. So sine squared 2y is also equal to 1/2 quantity 1 minus since 2y, so that is times 2, that is cosine 2 times 4, this is 8y dy. Okay, let's check our solution again. So 1 over 16 sine squared cosine 2y. So we let the power out. So the identities of this one, sine cosine 2y. Okay. Here 116. So since it's 2y 2 times, so this is 4. Okay, I've seen it. Sine 2y, so this is 4. Since we have a common here of 2. So it's okay, does not affect. So instead, this is a 4y. So that's why we got 8y. Okay, so it's clear now. Okay, so we carry out we carry out the real number constant again by applying our property number 2. This 1/2 times 1 over 164. 1 over 64, 1/2. Then we can copy this one. Okay, we'll make it short since we are out of space. I hope you can still comprehend with our solution. So 1/2 times 1 over 64 to 8. Okay, 1 over 128 integral of 1 minus cosine 8y dy. Okay, so what are we going to do with our function here? We're going to apply our property number 1. So we distribute the integrand and the dy inside the quantity. Doing so, that is 1 over 128 integral of 1 dy minus 1 over 128 integral of cosine 8y. Okay, we can simply integrate here because there's no other way. Okay, so it become y 128 y minus, you have, so if we're going to have a 128, so integral of cosine, that is sine, but you have an 8, so that is 1/8 sine 8y. Okay, we still rewrite 1 over 128 times 1 over 8. That is, okay, we can write our final answer, 128y minus 1/8. 4, 2, 1024 sine 8y plus your arbitrary constant. Okay, so this is your answer for your term number 3. If you're going to combine your term 1, term 2, and term 3, that is your answer here. So if we're going to rewrite, so our function here is 1 over 48. No, that is for your 2. Okay, so for term 1, 1 over 32y minus 1 over 128 sine 4y plus your second term, that is 1 over 48 sine cube 2y plus your third term, this 1 over 128 y minus 1 over 1024 sine 8y plus combining all the arbitrary constant, c. So this is your final answer. Okay, so this is your final answer for your problem number 13. If you have question, comment comment down below, message me. Okay? So let's proceed to our next example. Example number 14. So this is our last example for the transformation by trigonometric function formulas in a form of integral of sine raised to m x cosine raised to n x dx. So for your last example, this example number 14 can be found in your workbook on page 86. Evaluate the integral of x sine raised to 4 2 theta cosine squared theta d theta. Okay. So observe. Let's observe the given function. So by observing alone, we have an alien x. So it's not included in your derivative. So we assume it's a constant value x. So let's move by applying our property number 2. By evaluating alone the function. Okay, so let's move this x out, the integrand. So we assume it's constant value. Okay, so x integral of sine is 2 4 2 theta cosine squared theta d theta. So they are all in theta. Okay, so let's use some identity for our cosine. As you can recall, your cosine 2 theta is also equal to 1/2 quantity 1 plus cosine 2 theta. Where did we get this identity? Go back to your condition number 3, letter C. So you can see this transform this substitution value. Or we can rewrite. So x integral of sine raised to 4 2 theta. Oops, we need to rewrite it. We still have 1/2. Okay, so 1/2 quantity 1 plus cosine 2 theta. Oops, your d theta, don't forget it. Okay, next, so we have a real number constant 1/2. We can carry this out and combine these two functions. This 1/2, we can carry this out. So the x times 1/2, that is x over 2 integral of, so you're going to combine sine raised to 40 theta and 1 plus cosine 2 theta. So we combine this one. Okay, we rewrite. So that is, oops, don't forget your x's over 2 integral of sine raised to 4 2 theta. So that is times 1 plus, okay, sine 4 2 theta, then copy your cosine 2 theta, close with the parentheses, then your d theta. Okay, so what is our next step? We apply our property number 1. Let our x over 2 an integrand inside the quantity and our d theta. If we do that, it will be the result is 2 term. So this x over 2 integral of sine raised to 4 2 theta d theta plus x over 2 integral of sine raised to 4, 2 theta, cosine 2 theta, d theta. So now we have two terms. So we have two terms to deal with. We have our first term here, 1, and second term here, 2. So we need to solve them separately. So it would be easy and convenient, and to avoid also error. Okay, start with your 1. What is your 1? That is x over 2 integral of sine raised to 4 2 theta d theta. Okay, so let's maximize the power. We break it into 2. So xo integral of, so since we break it into 2, that is sine squared 2 theta na lang. Squared 2 times 2 is still 4, the same with this, and your d theta. Here we can use, of course, the identities. So we'll use substitution. So x over 2 integral, so sine squared 2 theta is also equal to 1 half quantity 1 minus cosine. So supposed to be this is only 2 theta, but we have a 2 here, so that is 4 theta. Then close parenthesis, then your bracket. This is supposed to be bracket. And of course, don't forget your power 2. You have a power of 2 and your d theta here. Okay, so next step is, can we carry out 1 half outside? No, we just apply our power, give it back. So give your power back inside. So if you're going 1 half squared, that is 1/4. Now we remove the bracket. So the remaining is 1 minus cosine 4 theta is squared d theta. Okay. So what are we going to do next? Sir, you can carry out that constant real number constant 1/4 and expand 1 minus cosine 4 theta. Yes, that's what we're going to do. So we carry out this constant. So 1/4 times x over 2, that is x 8. And the integral of, we expand this 1. So since it's a minus, 1 squared, still 1. Then 2. Then cosine 4 theta. Cosine 4 theta. Then is squared. And your 1 plus your cosine squared 4 theta. And of course, don't forget your root theta. Simplify x over 8 integral of 1 minus 2 still 2 cosine 4 theta here plus cosine squared 4 theta. Okay, so we apply property number 1. So we distribute x over 8 and the d theta inside the quantity. 8 over x integral of 1 d theta minus x over 8 integral of, you cannot remove the 2 from cosine because they are magkasama. So that is 2 cosine 4 theta d theta plus x over 8 integral of cosine squared 4 theta d theta. Okay, so what is our next step? It's getting heavy. So if we're going to use this one, okay, we can apply integration here right away. But here, we can still use identities. Cosine 4 theta, there is still identities. We used it a while ago. So doing so, 8 integral, the resulting is 8 x over 8, so the remaining is theta minus, if you're going to integrate 2 cosine 4 theta, that is cosine, that is sine 2 1/2 sine 4 theta plus, here we still need to do some substitution. Cosine 4 theta is equal to 1/2 quantity 1 plus cosine 4 times 2, that is 8 theta d theta. Whew. Okay, let's move to this place. So we rewrite our answer. Let's make it this green. Okay. So our answer is 8 over x over 8 theta. So here, so x over 8 times 1/2, that is x over 8 times 2, that is 16 sine 4 theta. How about our last term? So for our third term, we can move the real number constant out. So not, so the sign is still the same, that is plus, so x over 8 times 1/2, that is x 16 over 16, then integral of quantity 1 plus cosine 8 theta, okay, d theta. So here we can distribute x over 16 to our quantity. So plus x over 16 integral of 1 d theta plus x over 16 integral of cosine 8 theta d theta. Okay, we can simply integrate this right away. Okay, so plus 8 over 16, that is theta, plus your integral of 8/16 cosine 8, that is 1 over 8 sine 8 theta. Okay, of course, plus c. So rewriting our answer, okay, so we need to rewrite our answer. So we carry down this 2 term here. So finally, for your first term alone, you have x over 8 theta minus 8 over 16 sine 4 theta, then plus x over 16 theta plus 1x 16 times 8, 8. Okay, so this is x over 128 sine 8 theta plus c. Okay, so this is your c. So this is your first term alone. We still need to determine our, okay, I think there's still things to combine. Okay, we can combine these two. We have a common. Okay, so 8, that is 1 over 8, 1 over 16, x, so 3, 3 over 2, 4, okay, 16. This is 3 over 16 constant x. Of course, your theta. Then x over 16 sine 4 theta, and the remaining plus x over 128 sine 8 theta. So this is for your first term. How about for your second term? I think we need to go to our second page. We don't have much space here. Okay, so let's solve. What is your second term? X squared sine 4 2 theta cosine 2 theta d theta. Okay, so x over 2 integral of sine 4 2 theta cosine 2 theta d theta. This is our second term. Okay, so by observing its power, we can use our property number 3, correction factor. So we let Ru equal to sine 2 theta. If we get the first derivative for sine 2 theta, that is 2 cosine 2 theta. Therefore, our d theta is 1 over 2 cosine 2 theta du. Okay, we apply our correction factor to the function x over 2 integral of, we replace sine 2 theta with u, we copy our power, then cosine 2 theta d theta will be replaced with our correction factor 1 over 2 cosine 2 theta du. Okay, so we have do some cancellation. So cosine 2 theta, the remaining is x over 2. So real number constant, you have 1/2 u4 d theta. Okay, you can apply your power formula here. So that is x over 2 times 1/2, that is x4. So that is u4 du. If you apply your power formula, that is u4 plus 1, 4 plus 1 plus c. Okay, so that is x over 4 times 1 over 5 u5 plus c. If we're going to multiply x over 4, that would be x over 20 u 5 plus c. Then we recall the value of our u, that is sine, copy the power, 2 theta plus c. So this is your answer for your second term. Combining our answer, our second term. So what is our answer for first term? 3x, 16x. Okay. So your final answer for your example number 14, that would be 3x over 16 theta minus x over 16 sine 4 theta plus x over 128 sine 8 theta plus your second term x over 20 sine raised to 5 2 theta. Then combining all the arbitrary constant, this is your final answer for your problem number 14 or example number 14. So for comments, you can comment down below, or you can message me in our GC, or you can personally message me in your Moodle account. So for those students that would like to subscribe to our channel, subscribe to our channels so you can be updated and keep posted with our videos, tutorial for integral calculus. So here in engineering e-learning, we try to simplify, would be easy to digest and understand integral calculus. So we can say that it is a simplified integral calculus. It's not difficult, it's just easy to understand and digest it. So thank you for your time, everyone, and God bless you all and have a nice day.